You guys know this company?
Yeah, next door.
Yeah, it's next. Yeah, long story, but it's now next doors, but they messed up, so they got taken over. But Jacobs is here, ACOM is here in Oregon. Don't Flow, I think Tetra Check has an office here, HDR definitely has an office. So what I'm trying to say is Black and Beach, yes. Worley, yes, it's a smaller office. Stantec, yes. Burns and Mac, yes.
Oh, Burns and Mac. Okay.
Yeah. So there's a list, you can go through it, gives you some sort of ranking. It's got its perks, it's got its drawback. If you work for the top 10, there's a structure to it. If you work for bottom end of the list, you will, to me, I feel like if you're working at the bottom, you're going to become more of a rounded engineer because you're the postman, you're the cleaning lady, you are the janitor, you have everything. So you end up doing everything. So it's up to you. Anyways, so sort of showing that. And now let's go to a class example. And before I forget, there is a homework that's on week 4. But do yourself a favor, right after this class, you are prepared, like you have everything that you need to do homework to. And if you can get it done on Wednesday here, it will help you because you have a homework 3 due on the day of midterm. So, and I can't move the homework 3 that's due on the midterm because homework 3 covers transformers and your midterm is on transformers. Well, midterm also includes transformers, my God. So, for those of you who are just walking in, if you can try and get your homework 2 in on Wednesday next week, rather than waiting for 1 more week. Because if you lose this weekend over here, between week 3 and week 4, I have a strong feeling that you might end up in trouble with your midterms. Because the day of the midterm, there is a homework 3 that is due. So plan accordingly, and I now know what has happened. Used to be there was one of your labs is due somewhere here, and then there was a project, so it kind of made sense back in the day, but now do yourself a favor and get ahead of the game. And after today's lecture, I don't see a reason why you can't do your homework too.
Is there a way to modify that? I mean, there is very conflicted.
But it's up to you. I mean, if you feel comfortable, go ahead and drop it on Monday. From my end, I'm just warning you guys what is coming ahead for you.
So homework 3 and the midterm are gonna be due at the same time, same day.
Yeah.
Will homework 3 content be on the midterm?
Yes.
Yeah.
Ah,
It's like we have,
Fantastic.
yeah.
So let's.
I love that.
Yeah.
I love that. That's great.
Better understand it.
How many homeworks are there total? 6, right?
So let's go through a class example. I have written down the class examples here. You have a 3-phase variable frequency drive. VFD stands for variable frequency drive. Draws a lagging non-sinusoidal current. So this non-sinusoidal thingy should tell you that it's distorted. Most likely, we don't tell you. We just say non-sinusoidal line current. At times, in a good mood, we add a line or 2 to call it distorted. The VFD is connected to a 480 volt service. Sometimes we end up calling it PCC, point of common connection, which is where we hand over, like PG or Pacifico hands it over to you. So 480 volt service or a PCC, and your VFD draws 27 kilowatt. So if I give you 27 kilowatt, what is this power? Real, reactive, apparent?
Real. That's real.
Apparent?
Real.
Thank you. All right, and since it's a 3-phase, look at the currents. It's the harmonics involved are 1, 3, 5, 7, 9, and the currents involved are 37, 17, 15, 9, and 6. There is a 6 here. You may or may not be able to see it, but yeah.
Just a quick question. What does BFD stand for again?
Variable frequency drive. It's required to drive motors. We see that a lot in 348, but the drive itself is a John, have you taken a class with Dr. Jonathan Wood? No? Okay. Unfortunate, I saw the registration, so 13, 14, 15. I believe there were just 3 students who have signed up. So this year, if they have taken that class and just submit for any application with the sense that they have taken this class, there are going to be more jobs than the number of students that Portland metropolitan area is going to graduate. It's kind of, I'm like, yeah, cool, man. They have taken the class, it should be so easy for them to get that job. So, yeah. So if I give you this, and I ask you to find the line current associated, is it picture or video that you're doing? Okay, thanks. Yeah, that threw me off. What was I asking? Thank you. So if I give you the harmonics 1, 3, 5, 7, and 9, and I ask you what is the line current, what currents are you going to consider here? And this is 3-phase, it's non-sinusoidal, 480 volt, yeah, at this point you don't need it. But what is the currents that you're going to consider?
Can you ask the question one more time?
These are the currents that I see are coming out of my spectral analysis. If I want to, keep in mind, it's a 3-phase, so your 2, 4, 6, and 8 cancel out. You only have you only have first harmonics, 3rd, 5th, 7th, and 9th. I am asking you, I want you to come up with a certain current that will help you size the gauge and the breaker and whatnot. But how do you find that RMS current? What currents are you going to consider? I've given you 5 currents.
First, third, ninth.
You said first and three?
First, third, and ninth harmonic.
First, third, and 9, okay.
I would say 1, 5, and 7.
1, 5, and 7.
Yeah.
Okay, someone from here. Yeah, you were taking pictures. Yeah, go ahead.
Me?
Justina, yeah. Justina, right?
Yeah.
Yeah, go ahead.
I would go for
Don't say 2, 4, 6. It's not even here.
1, 5, and 9.
1, 5, and 9. I need one more. David, yeah, go ahead.
3 and 9.
3 and 9.
3 and 9.
Yeah.
Oh.
Yeah.
It's like the
Odd.
No.
No, it's the opposite.
Which is case.
Why do I need the triplets? Those of you who said 1, 5, and 7, you guys are getting confused with something else. That Guys, the only reason I'm picking you is I have a few minutes, so I'll say and shut up. I didn't want to say this. I accidentally happened to see your homework, and I was keeping away from Canvas. I didn't want to see your homework. I opened Canvas to download a lecture and make sure that the Fourier analysis lecture was on your course notes. And Canvas popped a message that I have to do something. And I'm like, what do I have to do? And it was some submission, and I clicked, and I saw that there are 19 homeworks, 18 from students and 1 a fake student. And then I had to look what's happening. And I looked through your last 2 questions, which is your FE questions. Most of you got it right. I think there's just 1 student who got it wrong, so which is like expected. Then I was like, yes, you guys are understanding everything. So I made the dumb mistake of looking at your first problem. And I just looked at the wire gauge because I wasn't interested in looking at the currents.
How many different answers were there?
Yeah, going with, I saw a 1 knot,
Whoa.
which is a pretty big. I saw a lot of students at 8 American wire gauge. 6 was there.
Yeah.
There was a bunch in 2, but I think there was something else, but it was a spread. So make sure that you understand what you're doing. Your FE problems gave me some sort of a hope, but once I saw the other one, I'm like, I literally told them that it might show up in the midterm, and they're still like struggling. I did a class example, like just gave it to you, and then I'm like, at that time I'm like, you know what, it's 1:30 at night, I'm going to bed, I'm done.
Yeah.
But yeah, so, and I wanted to say this at the end of the class, but this, you guys just made it interesting for me. So, I asked you to find the neutral current here, under the assumption that you guys know how to find the line currents at this time. I wrote this last time. Now I think I should have done the other one as well. But anyways, let's stick to our class, neutral currents. If I'm asking for a neutral current, And if it's a three-phase, in that case, pick up only the triplets, 3, 5, 15, 21, you get the idea. So I sort of did it here. So I just consider myself a bit on the low end of IQ, so I just write it out. I write my times table and that's knock out, and I'm like, oh, I need to pick the 3, the 9, the 15. What do I have? I have the third harmonic, I have the ninth harmonic. So my triplen is these two currents, the third and the ninth. Keep in mind, I went through an entire derivation where I said it's 3 times the triplen current. So this times 3. Please do not forget the 3. So you take your 17 square, you take your 6 square, that's these currents here, 16 and 7, and you do 3 times. You do your basic math, like find, I'm not going to go over how to find square root and what from. You end up with 54 amps. Now, the next question that I had for us, find the THD, so total harmonic distortion. To find the total harmonic distortion, I have to use any current other than the first harmonic. So I'll use the third, the 5th, the 7th, the 9th. See this 17 square? Apologize, I should go over the formula, right? So this is a H. H stands for harmonic, and H is equal to 2 to infinity. H is equal to 2 to infinity. Square of the RMS current, take the root, divide by the first harmonic times 100. This is true for both the voltage and the current, and this I picked up from IEEE 519 standard. So I have 17 through 6, I take the square and then the square root of that, divided by 37 times 100, 67.8. This number tells me that this is a highly distorted current, because I have way too much. And the truth be told, it's because of this third harmonic and fifth harmonic being so high. Yeah. And like I said, I regret not putting the line current. What is the line current? Because for the line current, did I end up doing it? So I ended up doing it. But this is, today I came to the class and did it. But anyways, so in case I was asking the line current, how do you go about it? You have to take all the currents, square it, and then find the root. So just for your, I didn't ask for the line current in this problem, but see this 37, 17, 15, 9, 6. You have to take all the currents, square it, and take the root to find your RMS line current. See that? So I went through the neutral current. I showed you how to find the THD for the current. I didn't tell you how to find the THD for the voltage. If it is not given, assume it to be 0, and I showed you how to do your true power factor with it. And I think I have a true power factor. Yep. Sorry. So now that we are here, I want you to focus on this guy, which is your true power factor, which is your displacement power factor. This is not PT, this is PF. Times your distortion power factor. Now, we just ended up finding THDI. I think it was 67 some percent. Yeah, 67.8. We do not know we do not know this. So if you don't know this, take THDW to be 0. So 1 plus 0 over this is 0, root of 1 is 1. So 1 times whatever this guy is. And that is, oh, I did it. 1 plus 0 over 100 square, which is dumb math, but still, times 1 divided by this guy, 67.8. Please take it in percent. Percent and percent cancel. you get a number, and that gives you the distortion power factor. And I believe it's 0.83 lakh, and this number is wrong. And I'll tell you why this number is wrong. Today when I was doing it, I again forgot the square. And I got a beautiful number which is 0.77, and that tricks you. These are pretty close. And please don't approach me if you forget the square. So it's 0.83 lakh, and that's your distortion power factor. Now we calculated this part, this entire thing. We still need to figure out this, we still need to figure out this. I just told you some time back that when you have, what is it, 27 kW? 27 kW? So you have your 27 kW here. This is 27 kW root 3. At this point it should be pretty clear why root 3. Your first harmonics voltage and the first harmonics current. This is 480. I don't have a second harmonic on the voltage. This is whatever was the current that I mentioned, and I think it is 37. Did I not do that? Yeah, I did it. So displacement power factor is 27 times 1000. 480 was the voltage. 37 was my I1 current, 60 hertz current times root 3. Keep in mind, those of you who are international students heading out to 50 hertz, so you'll have to keep on doing on the 50 hertz thing. So bear that in mind. You get a number of 0.88 lakh. So you have, we just calculated this. This is here. Multiply these two and you should get your true power factor. Now, there is an easier way to find true power factor, just in case if that's the question. All you have to do is, because this true power factor, let me just go back. Because this true power factor takes into account the displacement and the distortion. The way to do that is here. You have your P, which is 27 kW, root 3 to take care of three-phase line-to-line voltage or current. VRMS is 40 and your line current. So all these currents come into play. So in an exam, I'll give you a bunch of currents, ask you what's the line current, you have to consider everything. I ask you the neutral, consider the triplets. Keep in mind, three-phase. If I give you a two-phase, don't jump in and do 3 and 9. In that case, you have to look for the even numbers. And I would give you the even numbers, like, if it's a two-phase, I'll have all the numbers. And we just did a derivation where the neutral, at least for the neutral, the first and the third, or rather only the even numbers matter, and that's all you need for the neutral. But when you're doing the wire gauge for your lines, you have to consider all the currents. So same deal, it's dumb math but tedious math. Don't forget your squares. Don't add a square, don't subtract a square. Just don't do anything else more than what's asked of you. Keep my life easy. I just want to see those beautiful numbers anyway. So, and the policy does say that you guys can collaborate. The only ask is don't write, if someone wrote something stupid, don't just copy it over, so do what you have to do. It was pretty interesting. It was my first time looking at cameras from the other side. That freaking software just marked a few of your assignment as that, send it to a machine to check whether it is plagiarized. And I'm like, no way did a 1-0 guy and an 8 AWG copy. They're like, yeah, get out of here. But there is a way. I haven't used it. Kai might be relying on it. I don't know. What I'm trying to say is not for the homework. When you send in your lab reports, genuinely be careful. I didn't know Canvas had AI built into it, but turns out it is able to pick up. It's a third-party company which deals in this stuff.
They've also gotten it wrong, which has been a little scary for some students.
My feeling is it just looked at, some of you used engineering paper, and I think it just looked at engineering papers and brought all of them together. I don't know how it did it.
What?
Yeah.
Oh, that was horrible.
I don't know how it works. I could care less. Looking at the homework answers, I'm like, Yeah, they might have worked in a group, but the spread is so much that I could care less. So, yep. Honestly, that's it from me for the day. Next class, I would start on. Per unit and single line diagrams, and then transformers.
Hell yeah.
Thank you, guys.
Question about, homework grading?
I don't do it.
Well,
It's a grader who does it. He's been doing it for. He said he has been doing it for so long that he just knows the answer by it, that he does it.
well, I was curious, after